before. So what we had left in this problem was 3x squared minus 4 equals 0, and we solved this using square root property. So that's definitely something, I think that was the last problem we did. No, here's another one. No, is that the same? No. Here we go. This one was to the 4th power. Oh yeah, we stopped. We were out of time, but I didn't want to go on either. This one was to the 4th power. So you were being asked, I forgot what problem was in the book. You were being asked if x plus 3 is a factor, and that would be a yes or no answer. It is a yes, it is a factor if the remainder is 0. No, it isn't a factor if the remainder is not 0. So here we had 0, that means yes. And we also know now that x minus 3 is a 0, and that's where the graph crosses the x-axis. Okay, any questions up to here? A little summary of what we've done. Any homework questions before we move on? Yes, Tony Ann. 73, what section? 3.2. 3.2?
Yeah. It's a little back there, but I really
3.2, number 73. What is it? F of x, graph the function. Okay, 73. 73 on page 348. You have to graph f of x equals x squared plus 1, and x minus 2. Using described in this function, sketch the graph. And again, we're sketching the graph. So maybe the first step, or a good step, would be the first step. And I'm saying that in the first step. Okay, here's what I read in one of the polynomials. The first step is to make sure you have enough room on your paper. Yes, please. Make sure you have enough room on your paper, but that's really for something for everything that you need to do, not just for math. So it's always good to know that you have enough room on the paper. Okay, but the first step here is we have enough room, and has nothing to do with you guys, is the degree. What is the degree here? Degree. 3. Do I agree or disagree? I disagree. I disagree on that one. It's definitely more than 2. It's more than 3. It is 5. The degree is 5. Where is it coming from? Well, you have something. You have 3 factors here. X squared, that's 2. You also have an x squared plus 1, that makes 2. And then you see nothing, that makes 1. So the degree is 5. And the leading coefficient, is it positive or negative? Positive. I see no negative anywhere on the x, so it's got to be positive. So what do we know? What do we know about the end behavior of a degree that is 5 and the leading coefficient is positive? That is something you have to memorize. I can't stress it enough. It's going up. Up would be even. The 5 is an odd number. Yes?
Isn't the parentheses, isn't that always make it a 1? There's always a 1 on the outside of parentheses.
There is a 1, but not a negative 1. Yes.
Yeah, but wouldn't it add to the degree?
No, the 1 is the leading coefficient. That would be just a number.
Not in front of that, but at the end of the
No,
parentheses.
it really doesn't matter where you put the 1. If you put the 1 here, you mean this one?
The one to the left.
Here?
Yeah.
It doesn't matter where you put a 1, because a 1, it's a positive 1, is really just a number. You cannot put a negative 1 in there unless it was a negative to begin with. So, no, that has nothing to do with the degree. No.
I thought it was
No. No, not the coefficient just tells you if it opens up or if it is a reflection, really. That's all the number does. Tony Ann, you had a question?
How did you know that the leading coefficient was positive? And like, where's the,
I see no negative here.
so with the leading,
What you're doing really to find the leading coefficient is you would multiply your x term. So x, you have an x squared times an x squared, and here you have another x. That gives you your leading term. But there's no number other than 1 there anywhere. The 2 is negative, but that has nothing to do with the x. All the x terms here are positive. So if you do that, you add the exponent, that gives you an x to the 5th. To find this is factored form, so if you want to multiply them out and find the actual leading term, then what you do is multiply all your x terms together. If this would have said a negative 2, for example, then this would have been a negative 2x to the 5th. But there is no negative other than on this negative 2, but this negative 2 has nothing to do with the x. So it's positive. So that means on the left-hand side, your end behavior would be down and up. On the left-hand side, you go down. On the right-hand side, you go up. Okay. Now let's find the zeros. The zeros we find by either doing synthetic division or factoring, or if I already have factors here, I just set each factor equal to 0. So I have factors here, and what is my first factor? X squared. And if you set that equal to 0, you get x equals 0 with a multiplicity that is 2. And when the multiplicity is 2, does it cross or touch? Touch. So there's some touching going on. Touching going on right here at 0. Then let's do x minus 2 first. X minus 2 is 0, then x is equal to 2. And the multiplicity here by default is what? 1. If you don't see an exponent, it's always 1. That means this crosses. Just really crosses. It does not go like up and down, little wavy crossing. No, this is just basic crossing. Now the x squared plus 1 equals 0. Why was I hesitant with that one? If you set this equal to 0 and you solve, you get x squared equals a negative 1, right? And then you square root both sides and you get x equals plus or minus I, and plus or minus I is really an imaginary number that doesn't cross the x-axis. So I'm going to stay away from it. There's no crossing on this x-axis other than the 2 and the 0. And with the 2, I don't know if it's touching up like so. Touching looks like a parabola, the vertex of the parabola. Does it touch up like so, or does it touch down? We have to see how we can hook up. And the only other thing maybe that makes this a little easier to sketch is the y-intercept. The y-intercept, what is the y-intercept? If you set everything equal to 0, we already know that one of our 0 is 0, so that would be 0, 0. If x is 0, then y is 0. Okay. So, any thoughts? We need to be up here, and we need to be down there. So what do you think? Does this graph touch up or does it touch down? We got to come from the bottom here. We're coming from the left-hand side. This left-hand side is down. Now this graph doesn't cross anywhere here, so we have to hook up with my touching down problem like so. It's touching down, so let me actually delete this. If it were touch up, then we would have to cross it at some point, but we can't because there's nothing else there to cross it. And now we're going to turn and goes somewhat like that. Actually, we're going to go on Desmos and going to see how this thing looks like in the real world. This is a sketch. That's all I'm asking you to do. We can't plot the points of the imaginary zeros. They're somewhere in here. We can't see them. So let's take a look at Desmos and let's see how this looks like. Okay, what was it? Can somebody tell me was x to the second times x to the second plus 1, right? And you can already see, let's stop right here. X, we know that the plus minus I are imaginary. So here we can see that this graph really touches up with x squared equals 0. So it still looks like a parabola because these guys we cannot graph. And then we need what? X minus 2? Oh, we were pretty close with our graph, right? We just didn't know what, we made a sketch. We don't know how far this graph really went down. And that's not really what I'm asking of you. If I were to ask that, you would have to make a t-table, find the y value. Oh, I like those questions. Oh yeah, those are my favorites. Speaking of favorite, let's take a look before we move on, because that's definitely something that you will see on the test. I'm trying to, what am I doing? I'm trying to get back to my dossier here. I'm getting there. I gave you a handout. Does everybody have one? Yes. Let's take a look. Let me get to the end. Let's take a look at number 1. Ha, ha, ha. I shouldn't have put it all in one slide. So our graph was pretty accurate, depending. Okay, number 1. Let me make a picture real quick. I like those questions. Let me make a picture. What? Let me take a picture. Okay, number 1, you have a graph. You have it right in front of you. So is this function odd or even? Even? Everybody agrees? Okay. It's the leading coefficient. Here we go. We're talking about leading coefficient. Positive or negative? Positive, because it opens up. Think about the parabola. The parabola is even and opens up. what is the degree of this function?
3.
Well, Ethan, thank you for saying that. Ethan said at first 3. And that happens all the time, but you just told me the function is even. So therefore, just pointing out the things you don't want to do, the degree is even because it opens up. So the degree of this function is not 2, because if it was 2, it would be a parabola. So it's 4. And it is 4 because we have a turning point here, and we have a turning point there and there. We have a 0 that's crossing, but it's crossing in big style. Yeah, we get to this. Okay, list the zeros. So what kind of zeros do we have here? Yes?
I have a question. So this is basically what we're going to be having on the test?
Yeah, there could be some of these questions on the test. Yeah, I like those. Yeah, definitely. Okay, so let me tell you. So what are the zeros here? -2. -2 is right here. And what's the other 0? 1. That's all you see. Okay. The -2, what do you think, what kind of multiplicity that is? Odd, right? But give me a number in this case. Since you said the degree is 4, it's crossing. There's no fancy stuff going on. This is crossing right through -2. That means the multiplicity is 1.
How did you know it was going to be 1 and not 3?
Because 3 is the other one. If you have strictly crossing without anything that goes right so through the other 0, see, this one is crossing as well, but it doesn't strictly cross. It doesn't just cross. This one just crosses with nothing, I call it, fancy stuff going on. There's no fancy stuff going on. So that means the multiplicity is 1. If it's crossing where it's expanded right here on the 0, that means the multiplicity is greater than 1. And in this case, it has to be 3 because you told me the degree was 4. Okay, what is the factored form of this polynomial? Let's not worry about leading coefficients. Strictly the factors. What do you think is the factored form of this equation or this polynomial? If you have a 0 given, then you should know what the factor is. Yes, Nick? Say that again. I literally couldn't hear you.
X cubed plus 1 times x plus 2.
X cubed plus 1 times x plus 2. I give you the x plus 2. That is correct. Because where is it coming from? Because your 0 is -2, and if you put it as a factor, it's always opposite, it's x plus 2. But the x cubed plus 1, I don't like. It's got to be a factor, Nick. So if your 0 is 1, then your factor would be x minus 1, first of all. And that x minus 1 is raised to, the 3 is right here, to the third power. Because the multiplicity of the actual 0, which is 1, is always, it's on the outside. If you have your factors, these are your factors in parentheses, and you have a 3 here and a 2 and a 5 here. These are your multiplicities, and they are always on the outside. Unless your 0 is what? No, that would be also here, but unless your 0 is actually going through 0. If 0, too many zeros here. X is 0 with a multiplicity of 3, then your factor would be x to the third. Because it actually is x plus 0 to the third, but we don't say that. Okay, let's do the number 2 real quick because we gotta move on. Is this function odd or even, number 2? Odd. Is the leading coefficient positive or negative? Positive. You gotta look at the little table that we did. What is the degree of this function? 3. What are the zeros we have here? Negative 1, 0, and 3. All 3 of those zeros actually have the same multiplicity. What is it? 1, 1, 1. Especially since you told me the degree is 3. How do we know the degree is 3? We have 2 turning points, 1, 2. What is this equation in factored form? You got to look at your zeros. If a 0 is negative 1, what is the factor for negative 1? X plus 1. Always opposite. If the factor is, if the 0 is 3, what is the factor? X minus 3, x plus 1, x minus 3. If the 0 is a 0, what is the factor? Just x. It would be x plus 0, but we don't say that. Or minus 0, whatever you want to say. We don't say that. So it would be just x. Yes. Cool. Yeah, those are definitely some questions I like to ask on the test. Yeah.
Would you mark it wrong if we did x plus 0?
No. I would not mark it wrong. However, if you do x plus 0 and forget if the multiplicity is 4 and you forget the multiplicity of 4, then yeah. You could write x plus 0 to the 4th power if you want to write that. Yeah. Okay, we got to move on. So what we're doing now, we are talking about now finding the actual zeros. We did synthetic division, 3.4 and 3.5 is on finding the zeros. Let me see, I had something here, I think I did. Am I still recording? Yeah, it's recording. Good. 3.4, I just don't want to go to this one just yet. Maybe I didn't. Let me see what this is. Okay. Finding the zeros of polynomials in 3.4. Now again, the zeros are your x-intercept. So if you have a 0, either by factoring or by synthetic division, then whatever that 0 is, your factor would be x minus that number. Let me just make sure that you know the difference between a polynomial in factored form and not in factored form. Let's say we have x minus 3 to the third times x plus 5 times x plus 1 to the second. And then I give you a polynomial that looks like so. 5x to the third plus 2x squared minus 15x plus 10. I just so made that up. Can somebody tell me what is the degree of the first polynomial? What is the degree here? The degree is 6 because we're adding the exponent, and this polynomial is in factored form. What is the degree of the second one? The degree, 1, 2, the degree of the second polynomial is 3. Because the first one is in factored form, the second one is in expanded form. So we have a factored form and we have an expanded form. If I were to multiply my factors, that would lead into the expanded form. So if you have a polynomial that is already basically multiplied out, expanded form, then the term with the highest exponent is your degree. Here you have to add them. Here you don't. Don't get that confused. Happens all the time. Well, since we're at it, let's review what is the end behavior of the first polynomial. What is the end behavior of the first polynomial when the degree is 6? Up, because the leading coefficient is positive. What is the end behavior of the second polynomial? Down and up, because the degree is odd and the leading coefficient is positive 5. Okay, so now now I don't give you any hint anymore. So far, I told you what the zeros are. Now, I don't anymore. So, how do you get started, right? Well, there's a way to narrow down our zeros, and that is called the rational zero theorem, which is on page 365. Let's take a look at an example. So let's say you had f of x equals 2x to the 4th minus 3x to the 3rd plus 2x squared plus 6x minus... Give me a number. 3. Okay, let's use 3. Now this is a polynomial, and I ask you find the zeros. And you tell me, what? How do you want me to start that? Well, what we're doing first is we make a list of possible zeros. A list of possible zeros, and that's called the rational zeros theorem. That's hard for me to say, I don't know why. What we have to look at is we have to look at the leading coefficient, and we have to look at the constant term here, but let's not regard the sign. We don't have to worry about the sign. Now this, we call this P over Q. So P is our constant term, and Q is our leading coefficient. So to find the list of possible zeros, what you have to do is you have to find the factors of P over Q. Again, P is the constant term and Q is the leading coefficient. Now P, in this case, let's disregard the signs, is 3 and Q is 2. What you have to do now is list all the factors of 3, and to incorporate the negative and positive, we're just going to say plus minus here. What are factors of 3? 1 and 3. And I like to write them in the order from low to high. And now we're going to do what are factors of 2? 1 and 2. Now don't think of this as a fraction just yet. At some point it's going to look like a fraction, but not now. We're listing the factors of the constant term, and we're listing the factors of the leading coefficient. And we say plus minus because it could be a positive or negative. Now what you do, you take, always, you take the numbers on top, whatever you have on top, and divide them by the first number that you have in the bottom or in the Q, first factor of Q. So now our list would be plus minus 1 over 1 and 3 over 1. So you go with the numbers that are on the P, the factors of P, and you divide them basically by the first number factor of Q. And that's include. Okay, yeah. Now I'm going to use purple, and I'm going to go to the top again. The factors of P are now being divided by the next factor in Q. So this becomes 1/2 and 3/2. Guys, are you with me? 1 over 1, 3 over 1. Then you go back to the top and do it all over again. Go with the next one. 1 over 2, 3 over 2. So this is your list of possible zeros. Instead of looking at a whole bunch of numbers, we just narrowed it down to 2, 4, 6, 8. Why did I say 8? Because it's either plus or minus. So one of these numbers will be a zero of this polynomial. And how do you figure out which one it is? Well, now what you would do is you go down the list of, you take the number 1 and do synthetic division. If your remainder is 0, then jackpot. By the way, I didn't win the jackpot of $1 billion. I give you some money too, but I didn't win it. And I don't play lotto. I didn't even know the Powerball was $2. I thought that was $1, but I'm like, I'm going to buy a ticket. I teach statistics. I know not to do that. But anyway, so start with 1. You have to do synthetic division, plug in the 1, see if the remainder is 0. If the remainder is not 0, you go to -1 and do the same thing again. If the remainder is not 0, guess what? You go to your next number, +3. Then you go to -3. Then you go to 1/2. Then you go to -1/2. One of them will work. See it. My instructor always picked the one that's way down here. I mean, this list is fairly small. Sometimes you can have a list of 20, 30 numbers, and you're trying to figure out which one goes in there. For our purposes, I usually, because you can't be sitting here for hours trying to figure out which number works, I usually go with the ones or with the second factor. Okay, what do you think? I like it. Let's practice another one. Let's say we have f of x is x cubed minus 4x squared plus x plus 6. Now on a test, some students get mad at me. On a test, I say find the list of possible zeros, like for this first one. I made that problem up. I have no idea what the zero is, and I have no intention of finding it either. All I was asking you is find the list of possible zeros. Then on a test, I see students sit there for half an hour trying to figure out what the zeros are, which I didn't ask. It takes forever. I'm not giving you a polynomial where the zero is 23 or something. You either start with 1 or you start with the second factor, but that's about it. So they should be all easy to figure out. But all I want you to do is make a list. What is P over Q here? What is P? 6. What is Q? 1. Those are the easiest list you want to find. So now give me all the factors of 6, plus, minus 1, 2, 3, and 6. Now the factors of 1, well, that's 1. So my list of possible zeros is really the factors of p, because everything's over 1. So my list of possible zeros is plus, minus, you can put a parentheses around 1, 2, 3, and 6. One of them will work. And we're going to go through a problem in a second. And I want you to start with 1, and if 1 doesn't work, you go to negative 1. One of them will work. I'm not giving you something where you have to sit there for hours. Now, conjugate pair theorem, we already talked about that. If a plus bi is a 0, then a minus bi is also a 0. I told you they travel in pairs. If I give you a 0, let's practice that actually. If I give you the zeros, let's say x is 2 and 3i, and you have to find the polynomial. The zeros are 2 and 3i. You have to find the polynomial. I think I have a similar one on the handout. Now, what you want to do is write it out in factored form. What are the factored forms of these zeros here? If 2 is a 0, what is the factor? X minus 2. If 3i is a 0, what is the factor? Well, same thing, Mackenzie. X minus 3i. But now, I'm not giving you that. You have to know there's another one. What is the other one? X plus 3i by the conjugate pair theorem. They travel in pairs. That will not be given to you. That is your learning objective. So now since I told you, you have to know there needs to be an x plus 3i. Guys, are you with me? These are the factors. Now, if you wanted to multiply it out in expanded form, I would suggest always to multiply the x minus 3i times the x plus 3i. What is that if you multiply those two? Go ahead, do it. You know how to multiply. X times x, x squared. X times 3i is 3ix or 3xi, however you want to write that. What do you have left when you multiply conjugates? In this case, x minus 3i and x plus 3i. What do you have left? Definitely an x squared, right? X squared minus x squared. So then you do the minus 3xi. So that's minus 3xi. This cancels out. That's why we're doing that. And then you have negative 3i times a positive 3i. What is that? That would be negative 9 I squared. I times I is I squared. What does I squared stand for? I squared is -1. So this becomes, if you multiply it out, x squared plus 9. And that you multiply by x minus 2. That gives you x to the third plus 9x minus 2x squared minus 18. And that is your polynomial in expanded form. You can write it in descending order to make it look pretty. X to the third minus 2x squared minus 9x minus 18. That would be expanded form. Based on the zeros that I give you, you have to write them in factored form and then you multiply. Now on the handout, if you look at number 8, I don't want to do the whole thing, but if you look at number 8 on the handout, the zeros that are given are x equals -3 and x equals 7i. Somebody tell me how to write this in factored form. That would be x plus 3. Everybody agree? And? Now Nick already multiplied it out to x squared plus 49, but what are the other two factors? You are right, but let me just write them out. How did you get to the x squared plus 49? X minus 7i and x plus 7i. Again, that minus 7i is not given here. You have to remember that. And I don't want to multiply them out now. Let's do one more where we're looking for lists of, let me see what I have here. Number 13. Yeah, we're going to do number 13. Let's find the list of possible polynomials one more time. List of possible zeros from the polynomial. Okay, f of x is, do I see a nice one here? That's too easy. I'm gonna make one up. 2x to the third minus 16x squared plus 2x minus 12. There you go. List of possible zeros. What is P and what is Q? P is 12 and Q is 2. So what are the factors of 12? Plus, minus, 1. What else? 2. 3. 4. 6. And 12. There's a bunch. What are factors of 2? 1 and 2. So now we're going to make our list. Our list is plus minus. We take every single factor in the P and on the top, and we're going to divide it by 1, which is basically the same. So your list of possible zeros 1, 2, 3, 4, 6, and 12. That's all over 1.
How do you get the 1 and the 2 and the Q?
P is the 12, and Q is the leading coefficient, which is the 2.
I know, but under the 1, 2, 3, 4, and 6, 12, the 1 and 2.
Factors of 12. 1 is a factor of 12. 2 is a factor of 12. 2 times 6, 3 times 4. So that's my top. Now we go back to the top with a different number, different color. And we're dividing everything on top by the 2. So can somebody help me? 1/2 is definitely 1. Now the next one would be 2/2, which is 1, right? We already have that. We don't need to write that down. So then we go to the 3. That would be 3/2. 4/2 is 2. We already have that in our list. 6/2 is 3. We have that in our list. And 12/2 is 6. We already have that as well. So this is our list of possible zeros. And we're just making a list, guys. We're not finding them. Next one. Okay. Now we're going to find one. Now we're going to go for the whole thing. 13 on page 373 says f of x equals x cubed minus x squared minus 4x plus 4. And it says find all rational zeros of the given polynomial function. Nothing else is given than that. So first step is make a list of possible zeros. P over Q. What is our P here? And Q is 1. So plus minus 1, 2 times 2, and 4. That is my list of possible zeros. 2, 4, 6 of them. So now what I want you to do is you start with 1. The second step is start here with x equals 1 and do synthetic division. Okay, we're practicing everything today. Synthetic division, what are my leading coefficients? 1, and 4. And I want you to use 1, always. There are a couple other tricks on how you can figure out if 1 or negative 1 works, but I don't want to get into it.
Isn't it plus or minus? You don't have to do like 6.
And we're going to start with 1. You can only do 1 at a time. So we're going to start with 1, and if the remainder is 0, then we don't have to go through the other ones, because we already found 1 there. So we're starting with 1. If 1 doesn't work, we have to go to negative 1, but not all at the same time. That doesn't work. Okay, so bring down the 1. How do we do synthetic division? Somebody remind me. 1 times 1 is 1, and that goes underneath the second spot, and then we add, and that's a 0. 1 times 0 is 0, plus a negative 4 is a negative 4. A negative 4 times 1 is a negative... Oh, look at that, we got lucky! Well, like I already knew that. These are the kind of problems I have to give you on a test, because otherwise it would take so long. So, we have found 1 0. Yes, x equals 1 is one of them. How many more do we need to find? What's the degree here? 3. And we have 1. How many more zeros do we need to find? 2. How do we find them? Well, let's write out the quotient. What does this last row mean? We'll bring the x back. How do I write that as quotient? If this was x to the third, then this is 1 times x to the second. We're going 1 degree less than the original one. If we go in descending order, this would be x second, this would be x. We don't write that down, and we just have a minus 4 left. X squared minus 4, we're going to set this equal to 0. That's a quadratic equation we all know how to solve. Now life is easy and good. So we add 4 to both sides, or you can factor it, and you get x squared equals 4. Take the square root, and x is equal to plus minus 2. So the zeros for this function is x equals 1, the red one from what we started, a negative 2 and a positive 2. That isn't so bad.
So does that mean if we took like negative 1 and 2 and did it and did the synthetic division, we would have gotten the 0?
Yes, that is exactly correct.
And
Yes.
that's because we have a degree of 3, that's why we have 3 terms.
Mm-hmm. Yep. Cool. Let's do another one. Are you ready? Number 24, I guess. Number 20. I don't want to do 24 because I want to do some out of 3.5. Hold on. 24's taking so long now. Let's do number 14. Let's do 14. Let's do 14. 14 f of x equals x cubed minus 4x squared plus x plus 6. And we want to find all the zeros. Again, the degree is 3, so we need to find 3 zeros. Now let's make a list. First of all, what is p and what is q? 6 over 1, so the factors of 6 plus minus 1, 2, 3, and 6. That's my list. Okay, and we're going to start again with 1. We're going to do synthetic division. We'll start with x equals 1. My coefficients 1, negative 4, 1, and 6. And we're going to divide by 1. So bring down the 1. 1 times 1 is 1. Minus 4 is a negative 3. Negative 3 times 1 is negative 3. Plus 1 is a negative 2. Negative 2 times 1 is a negative 2. Plus 6 is 4. And you can see here that we don't get a 0. Okay, so that didn't work. 1 didn't work. Then I want you to go to the next one in the list, which is a negative 1. Always use a positive and the negatives first. And go in order of your list. So now we're going to use a negative 1 because positive 1 didn't work. Negative 1. Bring down the 1. We're going to do it again. Negative 1 times 1 is a negative 1. Plus a negative 4 is a negative 5. Negative 5 times negative 1 is 5. Plus 1 is 6. 6 times negative 1 is negative 6. Oh, 0. Yes, we found 1. How did I know that? Okay, we found 1. Doesn't that make you feel good? No? Now we're going to use the 1, the negative 5, and the 6, and we're going to write that as a quadratic equation. How?
X squared minus 5x.
Plus 6. That is the quadratic equation now that you have to solve, either by factoring or by using a quadratic formula. This can be factored. How do you factor that? x minus 3, x minus 2 equals 0, and then you set each factor equal to 0, and you get x equals 3, x minus 2 equals 0, and you get x equals 2. So your zeros all together with a multiplicity of 1 is negative 1, 3, and 2. How do you like that? I like it. Of course, again, on the test, not all homework problems are like this, but on the test, they either will be 1 or negative 1. Otherwise, it's taken too long. Let's do another one. Let's see. Hold on. Practice. Okay, I don't want to do this. We did this already. We talked about that already. Now, the conjugate pair theorem, we talked about that already as well. If a plus bi is a 0, then a minus bi is a 0 too. Now, we talked about that as well. A polynomial that is of n degree must have n zeros. And Mr. Gauss, yes, Mr. Gauss was responsible for the fundamental theorem of algebra. And what does it say? A polynomial must have at least 1 0. So Mr. Gauss said, we gotta have a 0. A linear has 1 0. So that is the fundamental theorem of algebra, and you have it in your book on page 377. He was the one, Gauss was the one who came up with this at the age of 20. Okay, now let's take a look. Let me see. Don't want to do this one. 29. Okay, 29 on page 382. We have x cubed minus 9x squared plus 25x minus 17. And again, find all the zeros. What is p in this case? 17. What is q? 1. So, factors of 17, luckily for us, there aren't many, so it's 1 and 17. And factors of 1 is 1 as well. So the list of our possible zeros is pretty small, plus minus 1 or plus minus 17. 4 of those numbers. So we're going to start with x equals 1. We're picking 1 out of our list. You do synthetic division and you tell me if it is a 0. Bring my handout, bring it again on Thursday. We're going to do a couple more problems here. Tell me if 1 is a 0. And the only way we can do this is through synthetic division. 1, negative 9, 25, and negative 17. I'm going to divide by 1. Yes? No?
Yes.
Yes? Colleen said yes, yes. Bring down the 1. 1 times 1 is 1, minus 9 is a negative 8. Negative 8 plus 25 is 17. 17 times 1 is 17. 0 it is. Beautiful. There you go. Yes. Yes?
Where did the 1 come from?
The 1 came from our list of possible zeros.
Yeah, but how did, like, the first one? I thought it was 0, right?
Oh, where's this 1 coming from?
Yeah.
That's your coefficient. It's not there, so it's understood to be a 1.
Okay, well, there's a 0 on top.
No, that was just a placeholder. That's just me telling you that you need to put a 1 in there. There you go. Good point. Okay, what do we have down here? We have, what is our quotient? We have to go on. X squared minus 8x plus 17. Can I factor that? Guess what? I can't, and I'm sure you can't either. So no, we cannot factor that. Which means, yes, quadratic formula. So you have to remember what's the quadratic formula?
X equals minus b plus minus square root.
Boo.
Equals negative b plus or minus the square root b squared minus 4ac up over 2a.
Here you go. Yes. Okay, what is A in this case?
1.
What is B?
2.
Negative 8. We're right here. And C is 17. Okay. X equals the opposite of B, which is a negative 8, is 8, plus minus B squared, 64 minus 4 times 1 times 17, all divided by 2 times 1. Calculator. $64 minus 4 times 17 is, what did you get? 8 plus minus square root of negative 4 all over 2, simplified. Well, let me simplify the square root of negative 4 first. What is the square root of negative 4? 2i all over 2, and that simplified is 4 plus or minus I. 8 over 2 and 2 over 2. So now the zeros of this problem were x equals 1, 4 minus I, and 4 plus I. You don't have to write it out. I just want to point it out that there are 3 of them. Yes, and sometimes they are imaginary. You have to remember the quadratic formula for this test. Do we have time for one more? If I give you a hint, then no, I don't want to do this one. What's 41? Let's see what's 41. No, I don't want to do this either. Here we go. We're going to do one more. P of x, I'll give you a hint here. 3x to the third minus x squared plus 12x minus 4. And I'm going to say use synthetic division with 1 0 I'm going to give you, and that 0 is 1/3. X equals 1/3 is one of the zeros. 1/3 is one of the zeros. Which is a possible zero? Let's see. 3, -1, 12, and -4. And we're going to divide by 1/3. Bring down the 3. 3 times 1/3 is 1. -1 is 0. 0 times 1/3 is 0. Plus 12 is 12. 12 times 1/3 is 4. And plus a -4. Okay, what do we have left here? What we need to factor? 3x squared plus 12 needs to be now solved. How?
Subtract 12 and move the 12 other sides, and then divide both sides by 3. Then you can do the square root of both sides.
X squared is -4. Take square root of both sides, and my answer here is x equals
2 and
plus minus 2i. Oh, yeah, -4. So my zeros are x equals 1/3, -2i, and positive 2i. And that's how we find zeros. We're going to find some more on Thursday. Practice.